Hello, ladies and gentlemen. We're going to continue our look at the 2003 7th grade level Gauss competition. We're up to question number 16, so hopefully you've given it a try. And let's grab our pen and our notepad and let's take a look. So triangle ABC has its vertices at 2, 0 for A, 6, 0 for B, and 6, 3 for C. The area of the triangle in square units is. Okay. So with a question like this, I like to always try and keep in mind that it's a grade 7 level contest. For many of you, this is probably the first type of contest you're going to be writing. You're not going to jump all the way to a grade 9 or something like that. You're going to start out slow and steady, and if grade 7 isn't what you're looking for, you'll bump yourself up to a more difficult contest till you find a nice challenge. But keeping in mind that it's a grade 7 level contest, I like to think through my solutions with sort of my grade 7 cap on. Now there are a couple ways to actually compute any triangle just given its coordinates, the coordinates of its corners, its vertices. One that comes to mind is, for example, there's a nice formula using cross products of vectors. But that is at best a grade 12 level concept and more likely something that you would see in a university linear algebra course. Okay? Many of you probably don't even know what a vector is, much less the cross product or anything like that. So with a question like this, yeah, there are formulas that you might know or have memorized that give you the formula in terms of the coordinates, but I bet if we draw a picture, there'll be a more simple something like a half base times height that'll probably come out as our solution here. So let's just draw the picture, plot those points, and see what we can see. Because there most likely is going to be a base and a height that are really evident. Oh, we're still on blue. That's okay. So, whoops. Starting to make marks on the previous question. That's not what we want. All right. We'll draw our x-axis and our y-axis. And our first point was at about 2, 0. And B was, I believe, 6, 0. And what was that other point? C was 6, 3, right? Yeah, 6, 3. So it's going to lie above B. It's at 6, 3. So our triangle, which we can do in another color, going to be right here. And you notice the line between B and C is parallel to the y-axis, and the line between A and B is it lies directly on the x-axis. So since the axes are perpendicular, you can actually tell this is going to be a right angle triangle. That's still, I mean, we don't even need that information. What we can see here is we have a base between A and B, and we have a height, because C lies at some point above them. How high is C above the base? Well, the base lies on the part where y is equal to 0. And C is 3 units above that, so it's a height of 3. How about the base? Can we tell how long the base is? It goes from x equals 2 over to x equals 6. That's a difference of 4 units. Well, the area of a triangle, 1/2 base times height is your most basic formula for a triangle's area. So that's 1/2, 4 times 3, or 1/2 of 12, or 6. 6 square units, I believe, is the unit type that they gave us. And 6 is C for our answer. So not bad. Now, if you did know some formulas, like Heron's formula with the distance formula, could probably give this to you. Or there's probably a nice simple two-dimensional formula just involving these coordinates. You could certainly use that. No one's judging you on the method you use to solve these questions. But, I mean, it's a grade 7 level. It's the basic contest that Waterloo puts out. It's probably going to have a very basic 1/2 base times height type solution. And there it is. Okay? So however you did it, C is the answer. We get 6 square units. That's great. and we look ahead to question number 17, which we're going to tackle in the next video.